Good evening again. We are now into taking a look at 7.6, and 7.7 will follow right after that. And that will conclude our instruction for Chapter 7 material. And then we get into the last Chapter 8 and 9. So let's go ahead and start in on looking at equations involving radical expressions, how we can solve them. I'm going to go through a couple different ways to solve the equations by sort of hand techniques, as well as showing you how to use the graphing calculator and the Desmos calculator to be able to solve these types of problems. Okay, so we'll solve radical equations, and then specifically we'll look at ones that are x to some power to k, and what we will do is we'll use radicals to solve this type of equation. So you'll see with these ones, we will use exponents to solve them. And with these ones, which are powers, we'll use radicals to solve them. Okay, so one of the rules we use is when we have an equation, we've got an equal sign. What this means is whatever's on the left side symbolically may look different, but conceptually they are identical. They look different, but they are identical. That's what that equal is saying. They're equally balanced as well. So think of them as being the same weight. So if we add something to one side, we keep the balance as long as we add it to both sides. But otherwise, we change the balance. If we subtract something from one side, we have to subtract the same thing from the other. So since the sides are equal, whatever we do to one side, we have to do exactly the same to the other. That maintains balance. So that's what's looking like here. And mathematical operations that preserve that balance, addition, subtraction, multiplication, division, and exponents. If we take, if the two sides are equal, A equals B, again, symbolically that looks different, but this equal sign says, hey, I don't care that they look different, they are the same. And if that's the case, then when we raise both of them to the same power, they're still the same. So that's the method we're going to use. Okay, so I'm also going to show you what if we graph one side, say as you'll see why I call this y1 as a one equation, y equals this one, and we graph the other side as a different equation, y equals 2. We'll do this, and we'll see the calculator does it. The place where they intersect, the x value where they intersect, is the x value that makes that we're solving for. Because remember, to solve means we take a bunch of math steps and we end up with x equals something, some number. That's what solving for x is. When we do it graphically, the place that they intersect, the x value of where they intersect, that is our solution. So I'm going to show you that right away. Let's go ahead and use the TI-84. This is the same way you would use an 84 or 83. I know several of you have this calculator. I'll also show you how you can do it with Desmos, which might be a little bit easier and accessible for those who don't have this calculator. So what we do is we graph the left-hand side, notice as y1. So we'll put in 4 square root 2. The x is the variable key, which is up here. And notice as I click things, the buttons turn red. Square root, 2x plus 1. And notice I keep this is all inside the square root. I'll just hit enter, and now I'm down to y2. What I put in y2 is simply 12, the number 12. And when you only have a number, what you'll realize what's happening is you get a horizontal line. Y equals 12 is a horizontal line at y equals 12. So doing it in this method, we also have to make sure our window will be able to see what we're looking at. So the x is going from -10 to 10. Right now I've got my y values going from -10 at the bottom to 150 in the top. I think that's a little bit overkill. I think I'm going to make my y max 15, because I know I need it to be at least 12, right? Because y equals 12, to be able to see that, I have to have my window above that. Okay, and so I will hit graph, there's the first y equals, that's 4 square root of 2x plus 1. Here's the second one, and all I got to do is find what that intersection is. There's a tool, if we hit second trace, which notice it's the blue is calc, so to do anything, each button has 3 options. The button itself, you push it and it will do it. If above the button it's in blue, you push the blue button and it will do the blue thing. If you wanted to do the green thing, you push the green button and it shifts it to the green function, which would be F4. And if your calculator is older, it might, instead of blue, it might be yellow. But to get the shifted function, notice I had to push the second button. I go here. What I wanted to do is I wanted to do the intersect feature, which is 5. I could just enter the number 5, or I can arrow down to it and hit enter. Now for the intersection, it's got to be on, what it does is it jumps to one of the graphs and it says, is this your first curve? And since we're on it, we'll say yes, enter. Notice it jumped to the second curve and it's basically asking, is this your second curve? We will hit enter to say yes. And then it asks us to take a guess, which you could move it closer to where that is if you want, or you could leave it alone, but you just at some point need to hit enter. And then what it does is it now tells you that the intersection is at x equals 4. That is our answer, x equals 4. So I'm going to write that up here. We just solved this equation. You could plug it back in and see if it works. 4 times 2 is 8, plus 1 is 9. Square root of 9 is 3. 3 times 4 is 12. It's going to work. I'm also now going to take you through sort of the by hand method to go through, but I wanted to show you that. And then the next one, I'll show you the use of, well, let's do it right now. We've got Desmos up. So I would do the same thing. Notice it doesn't have y equals. Now sometimes you don't have to, but I'm going to go ahead and just put y equals 4. Where's my square root? Here we go. We click on this thing, and where's the square root button? I don't see a square root button. That's strange. I'm sure I saw one before. Maybe I need to go full window. Let's see if that helps. Oh, there it is. Was it there all along? Or let's see, probably just because I went, maybe it was there all along. Sometimes you're looking right at something, 2x plus 1. And then I'll hit enter. It has graphed it. I don't see anything yet, but I'll show you how this one's a little easier to deal with. And then I go y equals 12. Okay. Let's go full screen. Notice I'm up. I can see where I'm at in the y value. So I'm just going to, let's get down here. There we go. And now watch, to find the intersection, and I can kind of either zoom in or zoom out here. That's kind of cool. All I have to do is click. That's the intersection. Boom, I click on it and it gives it to me. So that's why I like Desmos. It's a little bit more intuitive. You can move around the screen and such, but x equals 4 is our answer because that's where the intersection is. Okay, now let's walk through this. So what they do is they're going to isolate or get the square root by itself. So they divided both sides by 4. So that's how this became 1. And this side, 12 divided by 4 is 3. That's what they did. The next thing they're going to do is they're going to square both sides. Because remember, when you square a square root, make it to the second power, it undoes it. Okay, so they're going to square both sides. And again, that's because it's equal. We'll square both sides. Square root squared is just 2x plus 9. 3 squared is 9. And now we can solve this. So we'll subtract 1 from both sides. Okay, that's how we got the 8. And then we divide both sides by 2. Whoa, we got x equals 4, which is exactly what we got by both graphical methods. You can use any of these methods you want. This is all the steps you'll have to go through by hand. You use the graphing calculator or the Desmos calculator, which, again, to watch these videos, and you've got to have internet access. So you have access to Desmos. That's the main thing. And if you've got the graphing, the handheld graphing calculator, this is basically our lesson right now. We're done. Okay. So the check is plugged back into 4, which I did sort of visually. I said 2 times 4, and they actually walk through the steps. That's 8 plus 1 is 9. Square root of 9 is 3. 4 times 3 is 12. 12 is equal to 12, so it checks. It worked. Okay. So those steps we did is to isolate the radical, get the radical by itself. So we do that by either multiplying or dividing generally. Then whatever the radical, whatever power undoes it, it could be squared in that case, it could be a third or fourth or fifth power. We'll see some of those. We raise each side to that exponent, gets rid of the radical, and then we're able to solve the equation. And then the last step is to, once we have our answer, go back and check the answer. Or we simply could graph both sides. Okay. The thing with the graph both sides, that works for solving any equation. And you're going to see there's a little bit of a benefit, actually a lot of benefit by doing the graphical method. So this one, let's just go ahead and pull it up. Which one do you prefer? You want to, let's go ahead and take a look at this one. Desmos. So we just change this to, now that I know where my square root is, I go square root 6 minus x, and then I want to get out of this square root, so I arrow over, and notice now I'm outside of it, so I go subtract 3. Okay, make sure you get out of the square root. Okay, and then the other one is going to be y equals 1. So I graph both sides of the equation, click here, and what do we see? Let's get over here. Here it is. It looks like negative 10 is our solution. I click here, and it does tell me, because it gives me, see, if I click over here, and it's, I mean, I can get a point, but it doesn't stay. And I click over here, and I get a point, it doesn't stay. But when I click on an intersection, it stays. So x equals negative 10 is a solution. You could plug it in here, negative 10, negative, and negative, make a positive 10. 10 plus 6 is 16. Square root of 16 is 4. 4 minus 3 is 1. So again, we're going to see it all work out through there. Let me just remind you, and if you don't have a graphing calculator, you could fast forward through this section. So whatever works best for you. I'm going to clear that, and I'm going to go second square root. So notice the square root is above the x squared. I put in my 6, subtract x, and then I arrow out, so I get out of that square root, and I subtract 3. Okay, that's that one. I'm going to clear this one. I'm going to put 1. I'm going to graph it. We see the intersection over here, and it's just barely on screen, but we do see that they're crossing. Second calc, number 5, and then since I'm on one, I just hit enter. I'm on the other, I hit enter, and I hit enter again, and it gives my guess, and it says x equals negative 10. So we found the intersection. This one, to do it by hand, what they're going to first do is they're going to add 3 to both sides, right? They want to isolate, so they will add 3 to both sides, and you get the 6 minus x, square root of 6 minus x, and you get 4. 1 plus 3 is 4. Now they will square both sides. Yeah, see? Anticipation. Okay, square both sides. So on the left side, the radical will go away. On the right side, it becomes 16. And then we solve the resulting equation. So we will subtract 6 from both sides. That gives us our 10. And then they divide by negative 1, so that because we want x equals, not negative x equals. And that moves the negative over here. X equals negative 10, just like we found out from the graphing part. So now they're just going to do a check, just like we did. I did sort of verbally, mentally plugging in the negative 10. So they'll take you through the steps. Put the negative 10 in for x. This gives you square root of 16. Square root of 16 is 4. 4 minus 3 is 1. 1 does equal 1, so it checks. Cool, it works. This one, now if I remember right, this is the one, and there's a lot of steps here, so doing it graphically will be kind of nice. Let's see, how about I'm going to sort of stick with, just to kind of keep us moving, I'm going to stick with the Desmos because I know all of you have it. If you want some additional videos specifically on graphing with the TI calculator, I would be happy to do those too. Just send me a message. Okay, so what we put in here, now this one will be a little different because it's got, x's on both sides. So we do the square root of 3x minus 2. That's one side. The other side is y equals x minus 2. Okay, so those are our two. And then I can just click and I can just drag it over. And I see the solution right here. It looks like 6, but I just click. Boom, there it is, 6, 4. It shows me that's an intersection. X equals 6. That's our solution. Now you're going to see how much is involved in doing this all by hand. So x equals 6. We just graph both sides, find that intersection. The thing I like about this is it gives you the power to solve any equation known to humankind. Any equation you can think of, any equation that can be graphed, you can solve it by finding that intersection, because that's exactly what equals mean. That means it's the point at which both sides are equal. Now there's other values of x that these are not equal for. In this case, we can see there's only one, x equals 6. So I'm going to put that in here. Let's just go up here. We just solved it, x equals 6. We're going to see all the steps they have to go through to do this. What they're going to do is they're going to square both sides, right, to undo the square root. But notice now on the right side, we've got an x minus 2. We've got to FOIL this out. So we get this side, 3x minus 2. That's nice and pretty. It's really easy to deal with. But look what the right-hand side has become. We've got a quadratic. Now we got to move everything over to the quadratic side, get it equal to 0. We have to remember about our, see, I can't even remember. Yeah, factoring. We got to go back to factoring. How does this factor? Well, two numbers that multiply to give us 6, but add together to give us 7. Oh, it must be 6 and 1. And since this is negative and we're adding, they're both negative. Okay, so watch it. Yes, they did factor it, x minus 6, x minus 1. Notice we didn't have to do this because we just got x equals 6. And watch, you put 6 minus 6, that's 0. That is one of the solutions. But with this method, we actually get two solutions. Right? We get x equals 6 or x equals 1. But on the graph, we didn't get the x equals 1. Why not? Did we miss something? No. 1 is not a valid answer, but we don't know that with this method. What we have to do now is we really do have to check both answers. So we have to plug them both back up here and see if they work. So they're going to check. So we plug in the 6. This is this is what convinced me to use the graphing methods. I'm going, why? It gives me two answers and one doesn't actually work. But when I do the graphing, I never get a false answer. I just don't like liars, So we do this, the 6, you'll see, when you do both sides, you get, that's 18 minus 2 is 16, that's 4. This is 4, 4 equals 4. 6 works, we saw that graphically, it works. But watch what happens when we plug in the 1. On this side, we're going to get 3 minus 2, which is 1, is positive 1. The other side, we ended up with negative 1. Those are not equal. 1 does not equal negative 1. That's why 1 doesn't work. X equals 1 is a bogus answer. So using the by hand method, we had to do a lot more work. We had to remember our factoring, and it gave us an answer that wasn't true. So we also had to do all of this stuff where graphically we got our x equals 6. We're on to the next step. Okay, so that's why learning to use the graphing calculator or Desmos, any type of graphing method, is going to be nice. Okay, and now they're going to go through the graphing method. See, that's exactly what they say. See, the solution 6 is supported graphically. There it is. Where the intersection is 6, 4, the graphical solution does not give the extraneous solution. That's why it's so good. So let's just use it, huh? That's my preference. It will always work. It will always be, it should be easier. The hard part of graphing is sometimes finding where that intersection is, and so sometimes you have to look a little bit. But with decimals, the nice thing is we can just move that screen around till we find it. So that makes it easier. The TI calculator, you have to set your window, and so sometimes finding where the intersection is, that can be a little bit of work. I'll give you that part, but it's a lot easier than doing this stuff. Okay, again, we're going to have to isolate, but this one actually, you're going to have to square twice. This one is, let's just graphically do it, get our answer, and then let's laugh at them while they work it out in long steps. Okay, so we'll go to our decimals. I'm going to shrink it down so I can see what I'm putting in. I said stay down. There we go. So we're going to put in square root. Notice I just type over the top, right? 4x. Remember, I got to get out of the square root, so I took the arrow key over, and then I do minus 3, subtract 3. There we go. On the other side, I'm just going to highlight that. I do square root, and then I do x subtract 3, and it's all inside. Now notice I can see right here, it looks like they're intersecting. It's good. I'm going to hit the plus sign a little bit so I can zoom in on it. Yeah, it looks like they're crossing, and that's why I like decimals. I click it. If it wasn't intersecting, it wouldn't keep that dot there. See, if I'm over here where it's not intersecting, it shows it, but it shows me I'm just on one of these. I'm not on both of them. Okay, the only way you can get an intersection, when it shows the point, you know it's an intersecting point. So 4, 1, x equals 4. That is our solution. We are done. Let's go move on to the next one, right? But I'm going to show you what they had to do. Okay, so they're going to square both sides, right? Just give it a try, because that will make this square root go away. That's good, nice and simple, but look what it did to the left-hand side. We had to FOIL this out. It got real nasty looking. No other way to describe it. You kind of make it nicer, but look, we still got this. So now we're going to have to move everything over to the right-hand side. So you subtract 4x, or actually looks like they went the other way. They moved the x minus 3. So they subtracted x, so they got 3x. They added 3, so that became 12. And then they moved that over. And then what are they going to do? They're going to square both sides again. And so now we've got to FOIL this thing out. Whoa, it's getting really bad. And then remember, 6 squared is 36. The square root of 4, the square root goes away. Okay, I'm getting dizzy already. We're going to now 36 times 4, and then you're going to subtract it over, get it equal to 0, right? Because we need to do that. So that's 144x. Subtract it over. That gives us a negative 72. So plus 72x minus 144x. Then we got to factor this thing. Well, I know 144 is like 12 times 12. But 12, when I add 12 plus 12, I don't get 72, so it's actually going to be something else. What else is, see, I got to do all this factoring stuff. 36, let's just go ahead. 12, oh, because, yeah, I forgot there's this 9 up here, so this is 3x. And 12, that was a hard one to factor. I said I would have been spending probably a half hour, seriously. I would have spent extra time on it. Then you take the square root of, well, actually, this is 3x minus 12 times 3x minus 12, right? So we can just say whatever's in here, if it's equal to 0, it's going to be equal to 0. Add 12 to both sides, divide by 3. We got 4, but we were already there with the graphing method. Please use the graphing method. It makes it so much nicer. When you get to college algebra, that is the preferred method. If you can solve things graphically, you're going to do much better than trying to remember all these different things, because who's going to remember this? And even if you remember it, the factoring, that's, unless you're doing it every day, and I'm a math teacher, and I don't do it every day. So it's an archaic method. We've got the technology, let's use it, so that what we're doing is we're learning how to do math that gets us to answers, to get us data that we can make decisions. That's what humans are good for. We're really not, it's a waste of our time to spend doing all this calculation stuff. Okay, and yeah, you're saying, well, it's a waste of time to listen to you, little crow. Okay, gotcha. We'll move forward. Now, if it's a cube root, what we're going to do is we are going to, instead of squaring both sides, we will cube both sides. But let me show you something. Let's see if it works with decimals. Let's put this up. Do they have a, they don't really have a cube. They don't have a cube root. So you'll maybe remember that this is to the 1/3 power. However, I'll come back, I'll show it afterwards. I'm going to show you, sometimes it's a benefit. This TI-84 has some cool features, and one of them is, let me clear this out this time just so it's clear, is they do have a cube root function, and that's under the math key. So if you click on math, notice you just come straight down, you've got the cube root. You've actually got the x root, so you could put anything in there for x. I'll going to show you, you could do, let's just do it, number 5. So we could put a 3 in here. There is a dedicated one, so you don't have to do this extra step, but just in case you need a 4th root, a 5th root, whatever you need, you can put that in there. And then 2x plus 6. Again, as long as we can enter it, we can graph it. So it's learning all the different little tricks to get these graphed. And then the second side, remember, this is just y equals 4. I'm going to just hit graph, and let's hope we can see it. There's that. Now look at, this is where the problem is. I don't see an intersection here. They don't touch. So there's no solution in this window. But it looks like maybe if I go further to the right, maybe I'll find that. And so I come to window. Further to the right is our x maximum. That side of the window is x maximum. So I'm currently at 10. Let's try 20. It's not going to work. I've already tried this, but not quite. So I'm tired. Let's just go to 50. Okay, you just have to get big enough, but be careful. If I went to 500, it might be too big, and I don't really see it. Oh, I just said that. I don't go to 50. And then at 50, we see that, yes, they have crossed. And again, because it is in color, it's helpful. That's the other reason I like Desmos, is even if you have a TI-84 calculator, you might not have the color version. So second calc, number 5, intersect, enter, 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 tells me the intersection is x equals 29. So we're going to put that as our answer over here, x equals 29. Okay, before I move forward, I want to show you how you could use Desmos to do the same thing. What you need to do is, I think we did this in the earlier one, is we put the parentheses 2x plus 6, and then we're going to raise it, the exponent 1 divided by 3, 1/3 power. That's what a cube root is. So you just need to remember that part. And then over here, we'll just put in 4. Okay, so just remember cube root, a 4th root, just do it as a fractional exponent. We come back to our window. Let's make it nice and big. I don't see anything. Okay, here we go. What happened here? Do I got this right? Oh, there's that guy. Oh, but oh, here it is, way up there. Yeah, y equals 4. So what I'm going to do is let me get, yeah, so we push that, we get out. And then see, I just drag it over. I can see the intersection somewhere, and then I just, boom, hit it. Desmos is so nice to me. It just gives me the answer, 29. And if I want to save it, I click on the dot, and it makes it actually labels it for me. So 29 is our answer. X equals 29 is our answer. That's Desmos. Just know that you do it this way. Okay. And Desmos does have a lockdown browser. So I think what we're going to see is as teaching technology mentalities catch up with the technology, we're going to see internet type calculators or app type calculators like this, like Desmos, become more and more useful. Okay, so watch how they do it. They're going to cube both sides. So you do that, and then you get 4 cubed. That's 64. So we get some fairly large numbers, but not too bad. Subtract 6 from both sides. We got 58. Then divide both sides by 2. You're going to see x equals 29. That was not too bad, but graphing was okay too. Okay, so we do it either way. So then we check our answer, plug back in. So let's plug 29 in for x. Again, you could do it mentally. But that's the thing, is when you graph, what you need to focus on is that you've entered it correctly. if you've entered it correctly, it's going to graph it correctly. That's what machines are for. They're very good at following what you ordered them to do. And then you know you're going to have the correct answer. The only time you're going to have an issue, and students will say, I got a different answer than you. I said, you entered it differently than I did. Sometimes I'm the one who entered it wrong, but if we enter it the same, it will give us the same answer. So then we don't have to spend quite as much time. See, cube root is 64. Yeah, that is 4. 4 equals 4. It checks. Solution good. Okay. Now here we go. We could do this graphically. In fact, they're going to do it graphically. So I'm just going to click on this. And remember, we just did one. If we've got a fractional exponent, we can do that. X to the 3/4 power, right? You graph it. And this is the older version of the TI calculator, not as pretty and such, but you go through and you can find it. We'll show you, again, decimals, really nice. We'll just do x raised to the 1 divided by 3 power. No, not 1. 3 divided by 4 power. Okay, and then the other one is 4 minus x squared. And the thing is when we get to this, there's really no way to solve this because we've got a 3/4 on one side, we've got a square, we've got a, if you take a square root, it gets real messy to try to solve this by hand. There's really no good techniques. But see here, we've got it, and again, just click on it. There it is, 1.604. It's a decimal amount, but hey, it works. It is the intersection. And that's exactly what they got. See, if we put it in correctly, we will get the same answers. Okay, and our last thing is sort of, what if we have x to a power, so x squared, x to the third. We could take the radical of both sides. That will work. But again, graphically, works good. And it actually works better because what all this is, okay, when it's odd, it's clear. You're going to get one answer. But when n is even, squared, fourth, sixth, there's a possibility you're going to get a plus or minus. There's a possibility you're going to get an imaginary number, which we will talk about in the next section. And so there's a lot you kind of have to remember where when you do it graphically, just straightforward. It's just straightforward. So let's go ahead and do these just real quickly. Again, with decimals, it's pretty straightforward. We're going to x cubed. So this is x raised to the third power. And then what is this? This is negative 216. Now remember, negative 216, that's a y value. It's a horizontal line way down there at negative 216. So we see x to the third. So let's kind of get out of here a little. There it is. See, it's in purple. You can also change these. If you don't like purple, let's see, how do we do that? Click and hold on it. Double click on it. There we go. Click and hold on it. Let's say we want to make it red. There we go. It's a little easier to see. And then we click on the intersection, and it gives us the answer. The answer is x equals negative 6. Okay, so we're going to watch them go through it, take the cube root of both sides, cube root of negative 216. We could look on our list that we had from the last one, but you'll find that that is negative 6, because negative 6 times negative 6 times negative 6 is that. But we found that, where did we find that? We found it right here. The x value is the answer, the intersection. Okay, x squared equals 17. Okay, take the square root of both sides. Now, what they are able to do is, well, yeah, watch this, because if you put a square root of 17 in there, you actually get two answers. So let me show you this one. So we've got, instead of x to the third, we've got x squared, and we've got 17 here. Now, let's see, let's come up here. You see right away, we see that there are two intersection points, two places that it intersects. So we know there's two answers. They're the same thing. There's a negative and a plus or minus. If we plug this in, we'll see that is actually the square root of 17. So we get plus or minus the square root of 17. Okay. But what is the square root of 7? Well, it's about 4 point something, right? That's what we're getting. It's 4.123. And if you weren't sure of that, second calc, that's what's nice about this one. It's got both in there. Let's just check it out. Square root of 17. 4.123. There it is. Okay, so we can do it both ways. We can back substitute. Okay, so this one, what they're going to do is they're going to divide both sides by 3, and then they'll take the fourth root of both sides and go through, and do that. Again, you get nice answers occasionally, but a lot of times you don't. And again, with the fourth root, you got to worry about plus or minus. So what I suggest is let's just graph both sides. Don't do any algebra on it. Okay, there's that one. And then this one is not 17, it's 48. And we know where 48 is. We see it up here. And we see that there are two answers. We can click on this. One of them 0. Really? 0, 48. And the other one is -8. See, 0, oh, because yeah, plug in 0, you get 4. 4 to the 4th times 3 must be 48. Plug in -8. -8 plus 4 is -4. Take it to the 4th power. So again, graphically, we saw that there's two answers, and let's go ahead and let them work through this for us. They need a whole nother page to do this. So they divided both sides by 3. That's that. They're going to take the fourth root of both sides. Boom, boom. Fourth root of 16 is actually 2. Okay, you got to remember all these facts. Graphing calculator, we don't have to remember. And since this is an even, you have to remember what you have as the absolute value. So the absolute value means the inside part, x plus 4, is either equal to 2 or it's equal to -2 for this to be true. So you got to remember that splits off there. Here's another thing we didn't have to deal with. And watch this. We saw this. We'll subtract 4. We get -6. We subtract 4. We get -2. Let's back that up. Because I thought we had something. We had 0. What did I do? Oh, I know what I did wrong. You probably spotted it. I still have it squared. Okay, so that's why. Look at their answers. If you put in the wrong thing, garbage in, garbage out. Have you ever heard of that? My dad was a systems analyst programmer guy, and he told me that a lot. So get the right thing in there. So now that we've got the right thing, there's our -6 and our -2. We would have got the right answers. If Little Crow would have just put it in correctly, you will do better. Right? You probably saw me and were screaming, "Hey, Little Crow, stop." Okay, so that's the last one. Use Desmos. Use TI-84 calculator, whichever one works best for you, but use the graphical method for that, and it's going to make everything better. And in fact, you can go back and use it for all the other ones as well. So we'll take a break here, and then I'll come back and look at 7.7, and that'll finish off our unit for tonight's class. Thanks.